Hi from Gabriele of Stati Calmo, the statistical consulting service for companies below 50 employees that saves you from painful decisions thanks to various domains of statistics. Today we have a request that deals with human resources. The person says with a very rare tone, we are fed up with the churn in our department, and they refer to the marketing department. And they want to understand why people leave. That means workers. They want something quick and fast, something that it is not feasible, for a reason that you will understand. Here is the data. Attrition is our target variable, that is the churn or the worker that has left. Here we are in JASP, a statistical interface based on R mostly, and here is the department, and if you click here, you see that we don't have the department of marketing. So this is already a problem. I could stop here, but let's say that I want to understand which variables drive the yes. That means workers that leave the company. First, since we deal with a classification problem, in particular a 0-1 classification problem where 1 is yes and 0 is no, we have to check the frequency of our target variable. And to do this, we do a frequency table of the attrition, and we see that we have 60% for yes and 83% for no. This is the typical case of not balanced data, and if you want to do a model to predict this yes with the most basic statistical model for this, that is the logistic regression, it is a problem. Because hardly you can have an accuracy for this minority class above 50%, and 50% is the random coin flip. So if it is below 50%, you have to do something to fix this. The problem with the target variable inside JASP is that we can't do a correlation, to do a variable selection, to understand which variable explains the variable attrition. So we have to do something more messy that mostly who comes from computer science used to do. And that is, after I put almost all variables, here the quantitative and here the factors, I have different methods. And if I hit just enter, it produces a single model. And if I select backward, that is a method for variable selection, it produces, as you can see, 8 different models. Here it is not friendly for the common mortal, but one criteria for selecting the model is the AEC, that is a complexity index. The lower, the better. So, for example, if we take the 8th model, we see that this is the column for the significativity, and the statistical significativity is a way to do variable selection. And you notice that we have mostly significant variables. For example, this is not significant, the department, even though they asked for the marketing one. In number of companies worked, you have some not significant and some significant. We have 3 not significant because they are higher than 0.05, but since the majority are significant, we can leave it. Stock option, all significant, and educational field, everything not significant. Job level, everything not significant as well. So as you can see here, we have a lot of numbers, and I just focused on the p-value, that is the significativity for the frequentist approach of statistics. So if we take the last model I discussed, we have an accuracy for the no label of 97%, but for the yes label of 48%. That is less than the usual 50%. And this is the best model we can have. Of course, with such imbalance I showed at the beginning, you can't expect more from a model built as I showed till now. In the next model, I basically put inside the most significant variables of the last model it produced, and you see that here we have less variables, and we explain 41%. Now, since the logistic model has a different interpretation than the linear model, where there, for example, an estimate equals to 1 means that, let's take the age, for each unitary increase of the age, the y, the target variables, increase by 1. Here it is different because the model is built different. Here, to make things simpler, especially for who knows about sports betting, we can select into statistics odds ratio, and that is something more known compared to the estimate. So we see that the more the age and the less the person quits, because we have an odds ratio below 1. If it is higher than 1, the chance increases. And we can see that working overtime literally consumes people because they have an odds ratio of 6 that is very, very, very high. Now the problem is that we explain less than 50%, that is the flip of a coin. And one way to improve this is this. The logistic model does prediction from a probability, and the probability comes from the combination of those variables. But from the probability you have to extract the classification, the yes or no. And as I explained in a video that I put up, the default way to do a classification is if probability major or equal 50%, then yes, 1, otherwise no. But, of course, we don't have a law that says we can select a different number than 50%. And we can use a diagnostic plot, that is the ROC plot that comes from telecommunications, that inside here, as also I can show you here, we have the cutoff labels, and the cutoff is the threshold I mentioned. So instead of having 50%, can select 0.2 for the probability or 20%, and we see that we optimize the classification. If you don't do the so-called threshold tuning, one way to work with this imbalance is over or under sampling, so that you have a frequency similar of 50%. And this is something loved by computer scientists, but I honestly find it a bit harsh. Let's now discuss how to improve the model beside, let's call, statistical methods. As you probably saw inside those variables, we have, for example, job involvement and job satisfaction. Those are variables that in some cases are called internal variables. You don't have the variable that explains those variables, and if you find what drives those variables, they become better predictors than those ones. And my hypothesis is that many of those variables come from an internal survey, and most likely inside that survey we can find the item or question that drives the most the churn rate, so that people leave. This company might need a psychologist to go deeper inside such variables, also in case they didn't get such results from survey, but not the kind of psychologist that work into HR that I hate, but the kind of psychologist that comes from academia, and so have more experience with models that explore the interactions between variables, and they are pretty rare to find. So as you can understand, it would have helped if they gave also a data documentation beside the data that is quite rich in terms of rows and columns. Another idea for the model, beside the one typically used by psychologists, is a zero inflated model, because here we have a minority class. But this model has a downside. If you don't have domain knowledge, it can't work better than what I showed you. Domain knowledge here means this. Zero inflated models models the zeros and the one. And the one, you have to talk to the people to see if what they think drives people leaving actually results significant in the model for the label that indicates that people leave. This is all for this video. As you can understand, statistics can help you to not bleed in terms of workers, and thanks to a statistical analysis like this, you can understand how to hire workers that give you less problems and that have more pleasure working with you. Bye, and see you the next time.